Okay, so we're on recording number 5 here. This is going to be on D, statistical error. So let me give you the setup here. It's all in the words here, but I can explain it better in verbally here. I was going to say in person, but Beverly, you're not quite in person, but you're pretty darn close. So in this situation, what I'm going to describe as an example here is the asthma studies that I ran the first year we had this. Let's see, 1998. Emily, how old were you in 1998? 2. Emily was very young then.
I was 3.
You were 3. Mommy was at home watching you while I was doing my asthma classes at Rockford College in the Maddox Cinema. So anyway, what we did, the first time I ran an asthma program, I only had 7 people the first time I ran it. And basically what I did is I measured quality of life for people at the start of my program, and then I measured quality of life at the end. So what kind of statistical analysis would be appropriate there? I ran people, measured their quality of life before I started everything, but then I ran them through the program and then I measured them again at the end. Would it be an independent t-test, Emily?
No.
What would it be?
Within design?
Within subject design. It was a simple intervention design. Take people, measure them before, put them through my program, and measure them again at the end. So it was a within subject design intervention type. And so the idea is I measured all sorts of things. They had a lot of statements. And on these statements it said, I suffer shortness of breath. And if they had shortness of breath, let's see what I said here. A high number said they always had it. A low number means not so much. So what I did with these 7 people, if you look at the first one, shortness of breath, the idea is I asked the 7 people about this before, and let's say that for the 7 people, the mean, if you want to write a mean in, let's say the mean was 5. The mean before the program for the 7 people was 5. At the end of the program, the mean would be 4.5. So before the program it was 5, after the program it was 4.5. So the treatment effect then is what? If the mean before the program is 5 and after the program it's 4.5, Emily, what's the treatment effect?
It would be
0.5. I think I said it a little bit wrong. I said the mean beforehand was what? 5, and the mean after is 4.5, so the treatment effect is 0.5. It's a 7-point scale, so the treatment effect is 0.5. Do I want that number to be large or small?
Large.
Large. That's the numerator for the paired sample t-test. It's kind of a broken record, right? It's the numerator. We want the treatment effect to be large. So that was on shortness of breath. Standard deviation. You don't have to know how I got the standard deviation. What you need to know is, do I want that number to be large or small?
Small.
Small, because standard deviation reflects error. So standard D, you want to be small. And then the t-score, do you want that number to be large or small?
Large.
Large. A large t-score means significance. The final column gives you the probability. So was the result for shortness of breath due to my program, was it significant? Beverly, was shortness of breath significant in my program?
No.
No, because the probability of getting a t-score of 1.18 could happen due to chance 27% of the time. That is not significant. So you'd write T, what would it be? T6 equals 1.18, P greater than 0.05. P greater than 0.05. Program didn't work. Does anything on here, does it look like my program worked for anything on this chart? Does it look like T of 6 equals 1.18, Emily? 1.18, P greater than 0.05. Does it look like my program worked for anything in table number 1, year 1998?
Chest tightness?
Yeah, it looks like, look at the treatment effect, 0.75. So the mean before might have been a 5, after 4.25. Looks like people had significantly less chest tightness after the program. Anything else?
How do you get T equals 6?
Asthma control.
Yeah, asthma control. T of, say it again, Emily?
6. How'd you get T of 6?
There's no T of 6 in the top table.
Oh, I must have heard it wrong.
Degrees of freedom.
Yeah.
Degrees of freedom, that is. T of 6. Because there's 7 people. 7 people in the study. Yep. So it looks like there's a significant effect for chest tightness, T-score of 3. That could happen due to chance only 2% of the time. Then it looks like there's a significant effect for asthma controlling life. So it looks like we have, what, 2 significant effects, right? So, good ideas. Now, was anything close to being significant? Was anything...
Prevent achievement?
Yeah, it looks like we're pretty close on preventing achievement. Anything else? Marginally significant on that.
Restricted sport?
Restricted sport.
Restricting sports as well, and even feeling tired is kind of getting close. But we only have 2 significant results. Why do I only get 2 significant results here?
Because they haven't gotten any treatment.
Well, they did. They got my program. It's not a question of they didn't get it, because this is a treatment effect, before versus after.
Before they didn't get
No,
it.
this is the treatment effect is before minus after. It's the treatment effect. So my program did work. And actually, research has said that if you get a treatment effect with this scale, quality of life of 0.5, that's actually meaningful. It's clinically meaningful. I have a lot of treatment effects greater than 0.5. But only 2 significant results. Why is that the case? Beverly, let me ask you, why are only 2 significant here? No idea. Let's talk about how many people were run. How many people did I have in this study?
7.
I had 7 people. Think back to what we just talked about 5 minutes
We
ago.
need a larger sample size.
We need a larger sample. That this study in 1998 lacked power. We only had 7 people. The treatment effects are quite large. Research has said if you have effects of the treatment of 0.5 or greater, it should be meaningful in the real world. But I only ran 7 people. I lacked power. If I were to say my study only helped on 2 things and nothing else, there's a good chance I might have a miss, a type 2 error. I wouldn't want to do that. So what would be the fix?
Get a larger sample.
So get a larger sample. So guess what I did in 1999 when Miss Emily was, what, 3 or 4 years old?
In 1999, I was
4 years old in 1999. What do you think I did that second summer, Emily?
Got a larger sample.
You got a larger group.
I ran the same study again and collected the same data again. It wasn't actually a larger sample. It was the same thing next year.
Okay.
Why do you think I did the same thing the next year?
I don't know.
Because I could take all my results from 98 and 99 and do what?
Combine them?
Combine them. So if you look at Table 2, what does it say on the top of Table 2?
1998 and 1999. Okay.
It's when I worked with my mentor, Emily, Howie Zeitz in Rockford. So I ran it again in 1999, same thing, collected the same data. How does it look like in when I combine 98 and 99? I had 7 more people in 99. Do I get a lot more things here?
A lot more statistically significant.
Yeah, now I have good power. I have 14 people, and it looks like how many effects are significant?
2, 3, 4.
I got chest tightness. You can just make a little mark. Feeling tired. Restriction in sports. Preventing achievement. Asthma controlling life. Worried about the future. So I get a bunch of significant effects and even a few marginally significant ones. So let me make sure we all know how to report T-scores. How would you report the T-score for Table 2 for shortness of breath?
A T.
T, and what would be in parentheses?
6.
Nope. Remember, it was 98 and 99. 7 people each year.
So it's going to be 13.
13. T of 13.
Okay.
T 13 because I had 14 people
And then equals 1.59.
equals 1.59.
P is
P is what?
Um,
Beverly, what do you think?
less than 0.1.
We'll just say that it's greater than 0.05?
Yeah, if it's 0.15, you write P greater than 0.05. It's non-significant. Not even marginal.
Okay.
How about the next one, wheeze attacks? Is that significant? For 98 and 99? Emily, what do you think? Wheeze attacks in 98 and 99.
That is, well, it's above 0.05, so it is, not statistically.
Not statistically significant, but the term we would use now is what?
Marginal.
Marginally, and we'd say we don't, I mean, we could have a miss here, and we'd want to run more, but
So-
marginally significant. So T of what? T of
13.
13 equals 2, comma, P, 0.071, marginally significant.
MS.
What I'd like you to do for the homework is I'd like you to go through all of the results for Table 2 and write out statistical and real world just to make sure you know how to do it. So take each one and just write APA statements, statistical and real world. The other one I want to point attention to here. My program, although we did humor therapy and a lot of fun stuff in there, which one of these, psychologically, does my program look like it has no impact on?
Table 1.
Look at Table 2.
Oh.
Which variable does it look like my program had no impact on, even though we had a lot of fun in the program?
Shortness of breath.
Not quite.
Falling asleep?
No.
Oh, feel depressed.
Feeling depressed.
Feeling depressed. That my people were not depressed before and they were not depressed after. The treatment effect is nothing. That says that the mean before was what? The same as the mean after. Which is kind of weird because we really actually had a lot of fun. We did a humor therapy session and we all joked around and clowned around. But on the surveys, no change in depression. So take a look at that. The treatment effect is 0. So the numerator to the t-score is 0. The denominator is 1.1. The t-score. What does it say the t-score is there?
Less than 1.
Less than 1. What does that mean?
It means
There's more what than what here?
There's more error than...
Treatment.
Okay.
Yep, there's more error than treatment. And in this case, look at feel depressed even in Table 1. When you get a t-score less than 1, you don't even have probability. The way you write out this is if you ever get a T or an F score less than 1, in APA style, you just write non-significant T less than 1. You don't even have to write the whole APA thing out. You don't have to write T of 13. You just write T less than 1. Look at the example above. The t-score was 0.89. You just write T less than 1. Notice the probability due to chance is really high. What does it say? 78. So if you ever get a T or an F score less than 1, just say this result was non-significant. It means there's more error than treatment. And you just write T or F less than 1.
Okay.
So this is the situation of not having enough power the first time. If you have marginal significance, if you only have 6, 7 people, you don't have enough power. You'd want to run more in your samples so that you can really have hits. You want power to detect significant differences.
So, like, worried about future is going to be T13 equals 2.31, comma, P is equal to, and you actually put 0.04.
That's right.
Okay.
That's exactly right. So
Make sure.
this will be a good exercise for all of you to do just to make sure you have it. Send me a draft,
Okay.
and then I can make sure you're doing it right. APA, real world statements, just for Table 2. Beverly, is that good for you?
Mhm.
Okay, we'll stop the tape again.